problem. All right, everybody, welcome. Let's do some of these examples, just like that study.com video did. Here's a good marker. All right. I hope that video helped y'all get reacquainted with scientific notation from hopefully doing it before. Even if you didn't do it before, if you don't remember doing it before, we'll try it out. So this is the hard part, in my opinion. The converting from scientific notation to regular is real easy. If it's positive, you move the decimal to the right. If it's negative, you move the decimal to the left. And I'll show you what I mean by that in a minute. This one, you have to tell them where the decimal came from. So let's do an example. I'm going to do number 1, just in case you can't read that or in case it's too far over there for you to see it. I'm going to write it right here. Number 1, 45,700. There's not a decimal in here, like decimals are dots. There's no dot. Where's the decimal supposed to be, anybody? Yeah, at the end after the final 0. I know you'll probably know. So we're going to put it there just so we know it's right there. According to the video, I got rules up here too that if you'd rather read it than listen to a video. Personally, I would much rather read the instructions instead of listen. I'm not real good at listening and remembering things. I would much rather read it. But yeah, where's the video say that we're supposed to put that decimal when we start changing something to scientific notation? After the first non-zero number, yeah. I gotta fix this. So that would, in this case, that'd be after the 4. So if there actually is a decimal there, in our example, there's not. We put that there, so we can just say 4.57. But let's say that this says 45,700.1. We'd have to say 4.57001 times 10 to the something. But let's not, because it didn't actually have that decimal there. I just put it there so we knew where it was since it wasn't actually there. So 4.57, that's the first step. Put the decimal after the first non-zero number. The second step is write a times 10 to the, oh, we'll write in times 10, I guess. We don't need to write to the. See, I've got my steps right here on this paper assignment I used to give out back when we did paper things. All right, so here's the hard part. Write an exponent on the 10 indicating where the decimal used to be before you wrote it in its new spot. So that 10 is not very big. Times 10. All right, decimal used to be over here. We're given, so whoever is looking at our number that we're writing it for, they're looking at what we wrote down, and they're like 4.57. We have to tell them where the decimal came from. So it was over here. So we have to say, this decimal is here now, but it came from 1, 2, 3, 4 to the right. Wait, is that even 4? 1, 2, 3, yes. So that's positive 4. It came from 4 to the right, so positive 4. If you think about it any other way, because this isn't about moving the decimal, this is about where the decimal came from. Let's do another example. I guess we'll do number 2. Let's do number 2. 0.009. There's the decimals, in case you can't see it. All right. So first up, put the decimal after the first non-zero number, which is 9. Since it doesn't have a 0 after, we'll just say 9. And then second step, write times 10, times 10. Now we have to tell them where the decimal came from. So now our decimal is implied to be right there after the 9. So if we're saying it's right there, we're giving somebody this number, we have to tell them where the decimal came from. It's there now, it came from 1, 2, 3 to the left. So since it came from the left, it's a negative 3. And an easy way to check your answers and to make sure that you did this part right, since this is the more difficult part, rather than the other way around, is to go ahead and do it backwards. So 4.57 times 10 to the 4. 4 means move the decimal 4 to the right. So 5700, 5700. We did it right. Same with this way, 9 times 10 to the negative 3, the decimal's there. If we're doing it the other way, to go from this to this, negative 3 means move a 3 to the left. So 1, so let's see, 900, 900. And we did it. Get it. And I don't think I need to do other ones on this one. Let's flip the paper over. Here we go. Flip the paper over. And there. Are there any of these that we need to do? I'll do one of these. So I'm going to do number 20 over here. 7.121 times 10 to the 9. So we're doing it backwards now. Well, I think of this way as forwards. The way we were just doing it was backwards, but it doesn't matter. So we went from standard notation to scientific notation. Standard notation to scientific notation. Now we're going from scientific notation to standard notation. So this is the way that I think is easier. It's got a positive 9, which means you move the decimal 9 to the right because it's positive. 1, 2, 3. I better write this over here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 0. Man, a lot of zeros. Okay, put a comma there, there. Yep, times 10 to the 9 from our prefixes business, that's billions, right? And we got billions here, 7,121,000,000, and that's it. Does that seem all right? Okay. See if y'all can take that study.com quiz then, from the one that said, man, I don't know what it said, but it has a name.